Everyone. Welcome to today's session on light, reflection, and refraction. So, in the light, reflection, and refraction, first we will cover reflection. So, in reflection, we will cover the plane mirror. Okay. So, in reflection, we are going to cover plane mirror. So, in our daily life, right, we see mirrors almost everywhere, right? So, in our household, the first thing we see in the morning once we wake up is looking into the mirror. So how this mirror forms the image and yeah, what is reflection? We will see reflection of light. So let's say this is a plane mirror. Okay, this is a plane mirror which is polished at the other end. Okay, this is a plane mirror. It is polished at one end so that the reflection can happen, right? So if I draw a normal to this, right? So if I draw a normal to this mirror, if a light ray falls onto this, right? So the angle that the incident ray, so this is called incident ray. The angle with which the incident ray makes with normal is called the angle of incidence. Okay. Hope you're following, guys, right? So when a light ray falls onto a mirror, the angle between the incident ray and to the normal is called angle of incidence. Then what happens is this gets reflected back into the same medium, right? And this angle is called R, that is angle of reflection, and this is called reflected ray. So hope you're following, right? So in a plane mirror, what happens is the angle of incidence, I, is equal to angle of reflection, R. So that is for a plane mirror. So in a plane mirror, what happens is the total light falls on the mirror, gets reflected back into the same medium. Okay, same medium means whatever it is. If it is air surrounding that mirror, then the light gets reflected back into the air. Okay, so now here what we learned is incident ray and reflected ray. The angle that incident ray makes with the normal to the mirror, that is angle of incidence. And if it is the reflected ray with the normal, then it is angle of reflection. Now, there are two laws that the plane mirrors follow, right? Number one, so the angle of incidence is equal to angle of reflection. That's one law. And the second law that follows is incident ray, comma, normal to the mirror, normal, and reflected ray. Reflected ray all exist in the same plane. All exist in the same plane, or we also call it as medium, right? So if we stand in front of a mirror, right, so we can see our image, right? So we will see like what type of images that a plane mirror will form. Let's say I have a standing mirror here, right? So which has a rough surface so that the light doesn't escape from the other side. Okay. Now, if a person is standing here, right? If a person is standing here, if he's looking into the mirror, right? So this is the distance, you can say it as u, distance of the object. Let's say this is the object. This is what person standing in front of the mirror. Then we form a virtual image, right? So the virtual image will be formed. Let's say image distance is v. So in a plane mirror, what happens is the object and image. So we will see an image within in the mirror, right? So how we will see? We will see the exact image, right? So the size of object equal to size of image, right? So size of object equal to size of image. That's what we will see in a mirror. And also what we will see is u equal to v. U is what? Distance of the object from the mirror, and v is what? Distance of the object, distance of the image in the mirror. That's how we will, that's how it appears, right? So u equal to v. So what we can learn from here using the plane mirrors is, in a plane mirror, the incident ray and the refracted ray, the angle that it makes with the normal is equal, and we will see same size of the object and image, right? The image is same size as of the object, and the distance from where the object means a person is standing, that distance and the image that appears to be in the mirror is at the same distance. U is V. This is what the properties that a plane mirror exhibits. Okay, so the applications of plane mirrors are everywhere, right? So in saloons, in homes, right? Everywhere we use plane mirrors to see the images, right? All right, now let's move on to curved mirrors. So now we learned, maybe in your earlier classes, you would have learned more detailed about the plane mirrors. So I just gave the recap. Now let's look at curved mirrors. So how the curved mirrors behave, like how the image forms, right? Right. So in curved mirrors means a basic example I can give is uh, a tablespoon, a steel tablespoon. It's a tablespoon made of steel. If you see the top of the tablespoon, right? So it has a curved shape, right? So how the tablespoon appears from the side, if you see, right? So hold on, guys. So I think this is how the tablespoon is, right? I'm just giving you an example. So here, this is basically a curved surface, right? This is basically a curved surface. So if you see, one side is, it's like if we fold our hand, it's like a curved, right? So this is one side curved, and this side, it is up. So if I see from the side, it can be of this shape, right? If I see this side, this is concave shape. For the same spoon, if I am seeing from this side, this is a convex shape. So there are two types of mirrors, curved mirrors. Concave, which is like the projection is into, and convex. Okay, so there are two mirrors basically. So this is concave and this is convex. So concave. So a mirror, one end should be rough. That means one end is polished with something, painted with something so that the light doesn't escape. So this side is painted. That means if an object is here, right, then this side is concave. Then what is convex? That means for convex, this side is painted. That means the object can be this side, and this side is the mirror. Okay. So if we consider a circle, right, or a spherical object, then the inside of the spherical object is concave. The outer edge of the spherical is the convex. So what happens, like how light behaves when it falls onto a concave surface and convex surface? So that we will learn here, right? So let's see, concave mirror. So concave mirror is like we said, right? So this is the spherical and the other side is painted, right? So what happens is, so let me give you two examples here. Yeah, yeah, I have drawn with a free hand, so you need to bear with me. All right. So this side of the mirror is painted. So this is convex. So in a mirror, so the center point, we denote it as a P, that is the pole of the mirror, the center of the mirror. And if you draw a line perpendicular to the pole, that is the axis, principal axis, we call it as. It is the principal axis. Now, this curvature, if we draw this curvature, if we measure, there will be a certain radius, right? It's like a circular shape or a spherical shape. So there should be somewhere, there is a center of the curvature that is denoted as C. And from center to any point on the concave mirror, that is the radius of curvature, that can be denoted with capital R. So P is the pole of the mirror. It can be concave or convex, right? Pole of the mirror. And C is the center of curvature, and R is the radius of curvature. Now there exists a midpoint, right? So what happens is, if a parallel ray of light, right, parallel to the principal axis, if a ray of light comes straight and falls onto a concave mirror, so what will happen? So it should reflect. So how it will reflect? If you draw a normal here, the normal on a spherical path always run through the center. So if you draw the normal here, this is the angle of incidence. With the same angle, it reflects back through certain point here. So this is I and this is R. I and R are same in uh, the for the reflection, right? So it goes through a point. That point is called F, focus. Why? Because if any parallel beam of light falls onto the concave mirror, that reflects through this focus point. So that point is denoted by F, and that is called focus of that concave lens. So what is C? C is center of curvature. C is the center of curvature. And then what is R? R is the radius of curvature. Then what is F? F is the focus point. And what is P? P is the, what is P? Pole of the mirror. Pole of the mirror. Now, this axis, CP. CP is principal axis. You understood? And also there exists a relation between, what is this? C P FP equal to CF, that equal to R. R means the radius by 2. So this distance, PF means this distance, is equal to this distance. So CP is radius, right? CP equal to radius, and this FP and CF, F is a midpoint. F is a midpoint between C and P. So CF or FP is R by 2. Okay. So if you see an object is at infinity, there is an object AB here. For example, a man is standing very far to the mirror, for example, at infinity position. Then a parallel beam of light falls onto the concave mirror, and every ray, if you see here, this is the angle of incidence and this is the Angle of reflection that's going through the focus point. So what happens is, if a image, if an object is at the infinite distance, that can be formed as a dot, that can be formed as a dot at the focus, okay, in a concave mirror. All the parallel beam goes and converge at this point, that is F. Okay, and also this distance FP, right? What is FP? FP is called focal length of the mirror. So what is focal length? FP. FP is the distance between the focus point from the pole of the mirror. Pole is what? Center of the mirror, right? So pole is basically center of the mirror. So we can say pole or center of the mirror. So the distance between center of the mirror and the focus is called a focal length of the mirror and is denoted by small f. So concave mirrors. So what are the uses of concave mirrors? So concave mirrors, basically what they do is they form diminished and real images. Okay, they can form diminished and real images. Real images means if you keep something, that image can be formed onto that paper or whatever, right? A shadow image here, the image is nothing but a shadow that can be seen. Okay, so what are the uses of this? The uses of this are one, uh, a dentist uses mirrors to see the teeth, the enlarged teeth, right? So teeth is a very small in size, right? So dentists to operate, they use concave mirrors to see those images bigger. Okay, so anything that you want to see at a larger, as a magnified image, bigger image, what you can do is, if you can place a concave mirror very close to that, you can get an image that is enlarged, bigger in size. So in the next session, we will see how we will get image, a bigger image or smaller image, what type of image that we will get using a concave mirror. Okay, so for now, we learned what are concave mirror, what is concave mirror, and what different parameters that we have in a concave mirror, right? So now let's move to convex mirror. So convex mirror, what we said, it is the outer side of the spherical portion. So inside of the spherical portion is painted here. So basically convex mirror is something like this, right? So here, what, so the inside, so inside of the spherical portion is painted, and this side is the mirror which has the reflection. Now this is pole of the mirror, which is the center of the mirror, and if you draw a line passing through the pole, that is the principal axis, right? Now for this, which side the radius of center of the curvature will be? Somewhere here, right? Somewhere here, this is the radius of curvature, and the midpoint is the focus. And then what happens is, if an object is somewhere here, right? So if a ray of light, a parallel beam falls onto the convex mirror, what it happens is, so basically it starts reflecting. So how it reflects, let's see. So here, if you draw a normal to this mirror, so the normal can be something like this, that should pass through the center of the curvature, right? So here, this is like angle of incidence, and then something like this will be there, that will be your up. this is your angle of reflection, and this line appears to go through the focus point. You understood? So if a parallel beam of light to the principal axis falls onto this convex mirror, you can see that this is appear to be the reflected ray appear to be going out from the focus. So basically, this is like a virtual image, right? So what happens is, yeah, here we, in the convex mirrors, we form a real image. Concave mirrors forms real image, and here convex mirrors forms virtual images. Understood? So convex mirror forms virtual images. So here also it is same. P is the center of the pole, center of the mirror, and we also call it as pole of the mirror. And then F is the focus, C is the curvature, and this is R, excuse me, the radius of the curvature. So what is happening here? If you have an image, sorry, the object at infinite distance, a parallel beam falls onto the convex mirror, and you see like it is converging at focus, but it is an virtual image, very much diminished. Diminished means it's very small. It is just appears like a dot. If the object is at infinite distance and the mirror is, uh, if that object is, if we look that object into the mirror, it appears as a dot there. Understood? Now, what is here? What is the focal length? This PF distance. The distance between the pole and F is still the focal length, PF, that equal to focal length that can be represented by F. Okay? So this is F basically. From here to here, this distance is F, that is the focal length. Here also, same case. So the focal length, F, equal to R by 2, radius of curvature by 2. Okay. Now, what are the uses? In the next session, we will learn like what type of image, how big, how small, there's convex mirrors forms. So that we will see in the next session. But for now, we will learn like what are the uses of convex mirrors. So the rear view mirrors in vehicles, rear view mirrors in vehicles, or the examples of convex mirrors, right? So convex mirrors are used in the rear view mirrors, like to the side of the vehicle, we can see the mirrors, right? So in that mirror, the object which is behind, in this case, if a vehicle is behind us, so we can see that in the mirror, which it can magnify to certain extent, and that can be seen in that mirror. Okay, so that we will learn in the next session, like what size of image and where it appears. Okay, so yeah, so to recap, right? So what we have learned, so we learned about the plane mirror, and then we learned about what is a curved mirror, and in curved mirror, we looked at what is a concave mirror, and then what is convex mirror, and the various parameters, right? What is C, what is F, what is focal length, all that stuff. All right, so yeah, that's all for today's session, and I hope you all understood the topic, and I'll see you next time. If you have any questions or queries, you can contact me through my Urban Pro profile. Thank you, guys.